Hi students, welcome to Max Point of View. Today we are going to solve each and every theory question from the chapter Calorimetry, that too part A. So before starting our first question, my suggestion is watch the concept video. Okay, once you watch the concept video, you will get the concept. Okay, you will understand all the terms. Then this part will be very easy for you, or else you will face difficulty, and the words which we are going to use, specific heat capacity, all those things will definitely confuse you. After solving all these questions, we are going to solve each and every numerical which is there in the textbook. All those videos will be available in the description box. So without wasting any time, we'll start with our first question. Name the SI unit of heat. SI unit of heat will be joules. That's it. Joule. But you can write it in short form J. Our next question. How is the heat capacity of a body related to the specific heat capacity of its substance? Very simple. Heat capacity is equal to mass into specific heat capacity. In the exam, don't write it in short form, use the expanded form, specific heat capacity. If you want to show this in terms of symbols, C dash is equal to M into C. So C dash represents heat capacity, M represents mass, C represents specific heat capacity. Don't use short form, use the expanded form. Our next question. Name a liquid which has highest specific heat capacity. See, they are asking for a liquid, right? So that is nothing but water as highest specific heat capacity. Our next question, write the approximate value of specific heat capacity of water in SI unit. Very simple, they are asking in SI unit, keep that in mind. That is 4200 joules per kg per Kelvin. This is in SI unit. If they are asking the same question in CGS unit, the answer will be 4.2 joules per gram per Kelvin. This is in CGS unit. You will be wondering, converting from kg to gram, it should be multiplied by 1000, right? But it is divided by 1000. How? This is what we have learnt in concept video and also in numericals. Listen, whenever we convert kg to gram, it is multiplied by 1000 only. But where is the position of kg? Kg is in denominator. So if it is in denominator, instead of multiplication, we have to go for division only. Our next question, write the expression for the heat energy Q received by mass kg of a substance of specific heat capacity C joules per kg per Kelvin when it is heated through delta T degree Celsius. Very simple. Q is equal to, this is what we have learnt in concept video. Q is equal to specific heat capacity, mass of the body and change in temperature. The answer will be in terms of joules. That's it. Our next question, same amount of heat is supplied to two liquids A and B. There are two liquids A and B. Okay, liquid A and liquid B. Liquid A, so now we are going to supply same amount of heat energy. Okay, then liquid A shows a greater rise in temperature. See, this type of question we have learnt earlier itself. Whichever, so whenever there are same amount of mass, we have same amount of mass, that is not mentioned here. So we are going to assume it as same amount of mass and we are going to supply same amount of heat energy. Whichever rises the temperature faster, that means that will have low specific heat capacity. So the liquid A has low specific heat capacity. See, whenever the temperature rises faster, that means it has low specific heat capacity. In the exam you should write in the expanded form. But in this question, are they asking about specific heat capacity? No. We have to talk about the heat capacity. If the specific heat capacity is low, then heat capacity of A is also low. So they are asking us to compare, right? So heat capacity of A is lesser than heat capacity of B. That's it. This is the final answer. This is the reason. See, which rises the temperature faster? Okay, that increase in temperature in which liquid is faster? A. That means it has low specific heat capacity. If you have seen the concept video, this concept would have been very easier for you. Our next question, a liquid X has specific heat capacity higher than the liquid Y. So, specific heat capacity of liquid X is greater than specific heat capacity of liquid Y. First, we need to understand this statement, then only we can answer these kind of questions. See, specific heat capacity of liquid X is more. What do you mean by this statement? That means, assume both the liquids we are going to supply the heat energy. That means we are going to turn on the burner and we are going to supply the heat energy. For both the liquids, we are going to supply same amount of heat energy, which will going to get the high temperature faster liquid Y, because it has low specific heat capacity. Keep this in mind. If an object has low specific heat capacity, that means it will attain a greater temperature in a faster way. So we don't want that in a radiator, correct? So whenever we supply, okay, this liquid X, okay, if we supply same amount of heat energy whatever we have supplied to liquid Y, it will absorb the same amount of heat energy, but the temperature rise in temperature will be little slower. It will take large amount of time compared to the liquid Y. So in a car radiator, okay, what do you mean by car radiator? We have to use a water to reduce the temperature. So if we use liquid Y in car radiator, okay, once it absorbs the heat energy from the car radiator, the temperature of the liquid Y rises rapidly compared to X. So if we use that, temperature again increases in the car radiator. So for option A, it is liquid X. Now we'll go for second sub question. The heat reservoir to keep the juice bottles without freezing. Heat reservoir. That means whatever the liquid we are going to use, that should protect the bottle without freezing. Assume if we use liquid Y. Okay, liquid Y. What do you mean by temperature? It can be hotness or coldness, correct? So if we use liquid Y here in heat reservoir, okay, whenever there is a change in the temperature, okay, of the surrounding, this liquid Y will get the temperature faster. See, in both the way, if it is increasing the temperature or decreasing the temperature, liquid Y will get the temperature faster compared to liquid X, because it has low specific heat capacity. So liquid Y, if we use liquid Y, the temperature it is going to attain from the surrounding will be faster, then it will freezes. So it is not, we are not supposed to use liquid Y, we should use liquid X again. See, how to answer these kind of questions? Very easy. Wherever we require a liquid to protect it from a car radiator or heat reservoir, that should have high specific heat capacity. This is what you should have in your mind. For in both the cases, we are going to use liquid X only. See, in hotness, in coldness, it is going to take large amount of time to reach the temperature. So that is why we are using liquid X, which has high specific heat capacity. Define the term heat. Heat is a form of energy which flows from hot body to cold body when they are kept in contact. That's it. See, heat always flows from hot body to cold body. Keep this in mind when they are kept in contact. That's it. Define the term calorie, how it is related to joule. Very simple question. Listen, 1 calorie is the energy required, amount of energy required to rise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius. This is 1 calorie. The amount of energy required. The amount of energy required just to rise the temperature of 1 gram of water, okay, from 14.5 degree to 15.5 degrees Celsius. That's it. And how they are asking how it is related. See, 1 calorie is equal to 4.186 joules, or you can take it as 4.2 joules when it comes to calculation. This will be easy. Okay, you can assume you can take this one or this one, anything, you will get the full marks. Then see, this question has one more name. Instead of asking 1 calorie, they may ask you what is 15 degree calorie. 1 calorie is nothing but 15 degree calorie. In the exam, they may confuse you with this word also. So 1 calorie is nothing but 15 degree calorie. Our next question, define the term kilocalorie of heat. Very simple, similar to the previous question. In previous question, for 1 calorie we took 1 gram of water, correct? Here 1 kilocalorie they are asking the amount of heat energy required to raise the temperature of 1 kg of water from 14.5 degrees Celsius to 15.5 degrees Celsius. That's it. Our next question, define temperature, name it SI unit. See, very simple, this is what we have learnt in concept video. Temperature is a parameter which tells us the thermal state of the body. What do you mean by thermal state? Whether it is hot or cold, that is nothing but thermal state of the body, and it also determines the direction of flow of heat. Direction of flow of heat when two bodies with different temperature are kept in contact. This is the temperature, definition of temperature. The unit will be Kelvin, capital K. The SI unit of temperature is Kelvin. Our next question, state 3 differences between heat and temperature. See, whenever the difference they are asking, see in the board exam, most of the time they'll ask only one difference between two terms, because almost all the questions in the board exam of 1 mark. Most of the questions, okay, 99% of the questions will be of 1 mark. If they are asking for 3 mark question, okay, there will be 3 subdivision questions. So in the board exam they will definitely ask only one difference between any two quantities. See, here they are asking for 3, we'll learn 3. So in the board exam definitely they'll ask only one differences. So you are always, whenever they are asking for one difference, instead of going for definition, go for SI units. Then you will get easily full marks. Definition, I know you may go wrong, but when you are writing SI units, it is very easy, right? Just remember the SI unit of different terms, you will get the full marks. Now, anyhow, they are asking the 3 differences. Always go for definition first. On both the sides we have learned, right? Heat and temperature definitions. Second point, what is the SI unit of heat? SI unit of heat is SI unit is joules. Here SI unit is Kelvin, capital K. K should be capital. Then see, when it comes to heat, how it is measured? This is measured by principle of calorimetry. Temperature is measured by thermometer. That's it. See, write it in the form of sentence. These are the 3 differences they are looking for. Our next question, define calorimetry. See, calorimetry is different, calorimeter is different. Keep that in mind. Calorimeter is a vessel. Calorimetry is, it's a procedure. Our next question, define the term specific heat capacity and its SI unit. Listen, specific heat capacity definition we have learnt in concept video itself. Here I'll teach you the SI units. There are two units when it comes to specific heat capacity. The symbol for specific heat capacity is this one. C is equal to J kg per Kelvin. This is the SI unit. If they are asking for CGS unit, this is SI unit. CGS unit will be joules per gram per Kelvin. Everything remains same except this kg. So this is the CGS unit of specific heat capacity. The symbols are very much important when it comes to numericals. So C is specific heat capacity. If you write C dash, okay, on the head, if you write one more dash, just a dash, that is heat capacity. So be perfect while learning the concepts. Our next question, state three differences between heat capacity and specific heat capacity. See, as I told you, in the board exam they will not ask more than 2 marks. Most of the time they will ask only one difference between these two, any two terms. So here they are asking 3, we will learn it for 3 in the exam. Okay, which is easier for you? Always units are easy to get the marks, correct? Instead of going for definition, you may go wrong. If you are very perfect in the definition, please go for it. If you are okay, if you are not that comfortable with the definition, go for SI units, you will definitely get full marks. Okay, so see, I am not using the words, I am using symbols so that you will get to know all these symbols for numericals. For numerical sake, it is very much important. Listen, C dash represents heat capacity, C represent specific heat capacity. So C dash, it is HC, don't write it in short forms, this is SHE, okay, specific heat capacity. Now always the first one goes for definition, second one, okay, heat capacity depends on mass, and specific heat capacity, it is independent of mass. Okay, I know few students will have doubts when it comes to specific heat capacity does not depends upon mass, but in the formula we are using mass. So according to the formula, if we are using some physical quantity, that means the specific heat capacity should be depends upon mass, right? But whenever it comes to specific heat capacity, we always take for unit mass. Unit mass means 1 kg, that's it. So we are going for unit mass, that's why we are not considering the complete mass of the substance, we are using only unit mass. Unit mass means 1 kg of any substance, that's why it is independent of mass. Next, go for SI unit. SI unit is joules per Kelvin. Here SI unit is joules per kg per Kelvin, that's it. So these are the three differences. Our next question, what do you mean by the following statements? The heat capacity of a body is 50 joules. We have one more sub question. First we'll understand this one. Heat capacity of a body is 50 joules per Kelvin. If you know the definition properly, not by hearting, properly understanding, okay, then it is very easy to answer this question. Heat capacity of a body is 50 joules per Kelvin. That means 50 joules of energy is required to rise the temperature of a body by 1 Kelvin. To increase 1 Kelvin, okay, to increase the temperature of a body by 1 Kelvin, it requires 50 joules of energy. Then we'll go for second sub question. The specific heat capacity of copper, they are specifying copper, right? You have to use that word copper in the answer. The specific heat capacity of copper is 0.4 joules per gram per Kelvin. It means it requires 0.4 joules of heat energy to rise the temperature of 1 gram of copper by 1 Kelvin. So for 1 gram, we are talking about 1 gram, right? That is unit mass. So whenever the specific heat capacity comes, you need to use that word 1. Okay, if you don't use that word 1, you are not going to get marks, because the 1 gram or 1 kg, that depends upon the unit. Okay, if they have given 0.4 joules per kg, then you have to use kg, 1 kg. Here they have given 0.4 joules per gram, so we have to use gram. 1 gram. 1 gram is the key word in this question. Our next question, specific heat capacity of a substance A is 3.8 joules per gram per Kelvin and substance B is 0.4 joules per gram per Kelvin. Which substance is a very good conductor of heat? How do you arrive at your answer or conclusion? Well, see, this question is very easy if you have seen the concept video. Listen, first we'll write the given data. A is given as 3.8 joules per gram per Kelvin and B, it is 0.4 joules per gram per Kelvin. So to answer these kind of question, whenever when it comes to comparison, which is greater or which is smaller, you have to make sure both the units are same. If the units are different, we cannot compare the values. So if this is in kg, convert this one into gram, then both the terms will be in grams, then it is easy to compare the values. Now anyhow both the values are in same unit, you don't have to compare it to anything. Now which has the least value out of these two? This one 0.4, then B is the answer. Okay, B is very good conductor of heat. How can we say that? Very simple. I'll give you one example. Assume there are two objects, they have same mass and we have given same amount of heat energy. Okay, we have given same amount of heat energy and they are in same mass. Now which object will heat faster? That means which object's temperature will rise faster compared to A. Okay, in which has less value, that object, the temperature will rise faster compared to the another object. This is how we came to the conclusion. But what exactly you mean by specific heat capacity of a good conductor or a very poor conductor? Very simple. If it is a very good conductor, the specific heat capacity will be low. Keep that in mind. For a good conductor, specific heat capacity will be low. For a poor conductor, specific heat capacity will be more. Okay. Our next question, name two factors on which the heat energy liberated by a body on cooling depends on. Okay, very simple. First factor will be mass. Second factor will be specific heat capacity. Now onwards I am not going to use the this one expanded form, only the symbol. The third one will be temperature of the body. These are the factors affects a body on cooling. Our next question, name three factors on which the heat energy absorbed by a body depends and state how it does it depends on them. First we have to state and we have to tell them how it is dependent. That's it. Listen, the first one, mass. Mass of the body, it is directly proportional. Directly proportional. That means if the mass is more, okay, the heat energy absorbed will be more. So you have to write in the exam not in this way. Mass of the body is directly proportional to the heat absorbed by the body. You have to write it in the form of sentence. Mass of the body is directly proportional to the heat absorbed by the body. The same common sentence we are going to remove. Okay, next the increase in temperature. Okay, the temperature, you can write it as temperature. Okay, temperature is also directly proportional. How do you write in the exam? Temperature is directly proportional to the heat absorbed by the body. See, these are the factors. This is how it is affecting it. Next, okay, material of the body. That means what type of material, whether it is a good conductor or a bad conductor, all those things, material of the body. So it completely depends upon specific heat capacity. It depends on specific heat capacity. So in the exam, if you write SHC, they were going to give you marks that will be 0. In the exam, you should not write the short form. You should use the expanded form. Our next question, two blocks P and Q are different metals having their mass in the ratio 2:1. So there are two blocks P is to Q. There are two blocks. The mass ratio is 2:1. Are given same amount of heat energy. Now for these two blocks of metal we are going to give same amount of heat energy. The temperature rises by same amount. The temperature rises by same amount. Compare their specific heat capacity. If you see the question properly, they are talking about four things: mass, specific heat capacity, that is nothing but C, and Q, heat energy absorbed, and change in temperature. Okay, the temperature rise, that is also given. So out of all these things, which is the formula? We have to calculate specific heat capacity. So specific heat capacity is equal to Q by delta T. Okay, Q by M into delta T. So in this question, which are constant? Which are constant? That is nothing but which are same amount of heat energy is given. So we can cancel that. Same amount of rise in temperature, we can cancel it. In the formula, you have to see the question first. Whichever has the same quantity, heat energy is supplied is same, and rise in temperature is also same. So we can cancel it from the formula. So we have remained with C is equal to 1 by M. C is equal to 1 by M. Now we have to compare their specific heat capacity, Cp by Cq. Comparison means it should be in the ratio of 1. First we'll find the answer in terms of fraction. That will be nothing but the ratio form. So specific heat capacity of P, that is nothing but 1 by this one. Mass is given as 2, correct, for P, and for Q, this is Q, mass is given as 1 only, but here C is equal to 1 by M. So 1 by 1, 1 by 2 into 1 by 1, that is nothing but 1:2. Okay, see here we got the formula. Whatever the mass is there, you have to replace, substitute in the denominator. So first P, okay, for block B mass is 2, so 1 by 2, and for Q mass is 1, that is 1 by 1. So when you put it in fraction form, you can write it like this, and final answer will be 1:2. This is the required answer. So finally Cp is to Cq is equal to 1:2. That's it. Our next question: what is the principle of method of mixture? What other name is given to it? Name the law on which the principle is based. Okay, all the three questions are very simple. Listen, what is principle of method of mixture? That is nothing but heat energy lost is equal to heat energy gain. See, in the exam, whenever you are writing the answer, you should not use, whenever you are writing the answer in the form of sentence, you should not use the symbols. So you have to write the full form of is equal to. Okay, you should not use the symbol. Heat energy lost is equal to heat energy gain. That is the principle of method of mixture. And they are asking what is the another name for it. That is nothing but principle of calorimetry. This is the another name for principle of method of mixture, and they are asking name the law on which this principle is based. This is based on law of conservation of energy. So how can you write these kind of laws? See, whenever the input energy is equal to the output energy, then that is nothing but law of conservation of energy. How much lost is there, that will be equal to gain. So there is no waste of energy. So that is nothing but law of conservation of energy. Question number 16, 17, 18, 19 and one more question. All these questions we have discussed during the concept video, correct? These are just give reason questions. Instead of explaining it, we can move on to the further questions, because all these things we have understood in depth in the concept video. So there is no need to learn here. The same thing whatever we have learned there, that is what we are going to learn here. So we are going to skip these questions. Our next question, what is calorimeter? And we have many sub questions. First we will solve the sub question A. Okay, calorimeter is a cylindrical vessel cylindrical vessel which we use to measure the heat energy lost or heat energy gained by a body when it is mixed with the another object or another body. This is nothing but calorimeter. Next, we have few sub questions. Name the material of which it is made up of. Very simple, it is made up of thin sheet of copper. Okay, and they are asking two reasons for using the material stated by you. Why we have to use thin sheet of copper only? Because it is very good conductor of heat, it has low specific heat capacity. These are the two reasons why we have to select the thin sheet of copper. Then we have some more sub question. Out of three metals A, B, C, okay, there are three metals A, B, C, and the specific heat capacity is given 900, and first thing you should make sure that all the units are same. 900 joules per kg per centigrade, 380 joules per kg per centigrade, and 460 joules per kg per centigrade. In all the values, units are same. See, joules per kg per centigrade is nothing but joules per kg per Kelvin. Both are same, don't worry about it. Now, out of first thing is, we need to see all the units are proper, all the units are in same, all the units are same. Next, we have to see the lowest value. Why? Because that is why we have selected copper here, right? So it has low specific heat capacity. Out of all the three, which has low specific heat capacity? The object B, correct? So object B is the answer. You just write material B, you will get full marks. No need to write it in the sentence form also. The material B is used because it has low specific heat capacity, all those things. So they are asking reason, right? They are asking reason because it has low specific heat capacity. Then our last question, how is the loss of heat due to the radiation is minimized in a calorimetry? Very simple, this is what we have learnt in concept video. By polishing the outer and inner surface of the calorimeter, by polishing that, we can aram say minimize the loss of heat due to the radiation.